Hello everyone, welcome to, I think this is the last speaker series we've got. And today we've got Mitch and some other academics from ACFR to talk about their projects. So I'll hand over to them in a second. If you've got questions, feel free to drop it in the chat. Otherwise, there'll be a bit of a Q&A after.
Hey, thanks a lot, Tara. My name's Dr. Mitch Bryson. I'm the undergraduate stream director for the mechatronics program at the University of Sydney. I'm joined by Dr. Don Dansereau and Professor Ian Manchester, and we're just going to give a bit of a talk about some of the research activity and some of the projects that are going on at the ACFR, which is the Australian Centre for Field Robotics. It's one of the big research institutes within the Faculty of Engineering and in the School of Aerospace, Mechanical and Mechatronics Engineering. We're going to also talk about CIRIS. It's the Sydney Institute for Robotics and Intelligent Systems. And so there's a couple of other academics who work as their research as part of the Australian Centre for Field Robotics and CIRIS, who are in the room as well today. So we thought it was just a bit of an opportunity to talk about some of the work that we're doing. There'll be a bit of chance for questions and answers at the end if anyone's interested in finding out a bit more about some of the research projects. And I will sort of hand back and forward between some of the other academics who are here today to talk about specific types of research projects and research areas. I'm just going to try and share my screen and hopefully everything goes to plan. Just check everyone can see the slides there. All right, great. Okay. Okay, so everybody here's probably maybe heard of the Australian Centre for Field Robotics or the ACFR, where in some sense we can think of ourselves as the kind of research arm of the Sydney University Mechatronics program. If you're kind of thinking about a student, yourself as a student is rolled in mechatronics, sometimes we think of the undergraduate mechatronics engineering program at the university as being kind of the teaching arm of the Australian Centre for Field Robotics, depending on which way you're kind of looking out or looking in. We're basically one of the largest robotics research groups in the world. So globally, we're one of the biggest, really exciting place to be here in Sydney. It's really one of the most, biggest groups that's doing kind of robotics in the world. When we talk about field robotics, really what we're talking about is robotic systems that are designed in some sense to operate out in the field. So we do a lot of work in kind of harsh environments. We've got a team that does work on marine robotics. We do a lot of work in things like autonomous driving. We've got robotic systems for agriculture and mining and lots of other kind of harsh environments that we're deploying real robotic systems in. We've been around for quite a long time. We're celebrated our kind of 20-year anniversary. I think it was maybe a couple of years back now. We've got quite a large budget in terms of funding that's coming in from research funders, from industrial research projects, also research grants. We have a large portion of our kind of annual budget comes from our partners in different industries in which we're deploying robotic systems and applications. So we do a lot of work closely with real applications. We've got around about 130 research staff when you kind of count up everyone that's involved in the centre. So we've got around about 10 academic staff that are comprised of mainly the types of academics that you'll see in the classrooms who are teaching you different subjects as part of the mechatronics program. We've got about 40 research fellows, which are kind of dedicated to performing research. About 30 PhD students, so students who are doing their postdoctoral research, doctoral research degrees. And we've got a team of about 35 technical staff that are there to kind of support the industrial projects, building and operating the robotic systems that we work in our research projects on. And we've got a large number of affiliates and visitors associated with the centre. We've got 3 kind of dedicated campus buildings plus a farm where we kind of operate robots. So offices, field labs, workshops. We've got an underwater test tank, an optics imaging lab as part of our systems here at the university. We have a farm in Marulan, which is around about a 2-hour drive south of Sydney. And we've used this farm for a number of years. There's a larger airstrip there. We can do operations with pilotless aircraft systems, a lot of ground operations, when we need a bit of a bigger space than what we have available in the city of Sydney. And we do a lot of work, everything from sort of fundamental science in autonomy and robotic platforms all the way up to applied research projects. There's a real focus, I guess, in the research on having an impact that benefits society from different automation and robotic solutions. So another part or related kind of research group as part of the ACFR is the Sydney Institute for Robotics and Intelligent Systems, which is kind of a superset, I guess, of the ACFR that is a university-wide research institute, sort of looking a little bit beyond field robotics, which is the kind of main bread and butter of the ACFR. So moving into systems such as, how do robots interact in society and other human-built environments, looking at applications as robotics in medical environments, medical robotic systems, robotic surgery, robotics for healthcare and well-being, human-robot interaction and all of the sociological kind of factors. And then we have people who are associated with the CIRUS, which look at things like the legal frameworks behind integrating robotic systems now into kind of everyday environments, and some of the ethical considerations behind large scale automation of things that in the past humans have been mainly involved in doing. A lot of stuff in infrastructure and city planning, and some related domains in things like augmented, virtual reality, mixed reality. So CIRUS, in a sense, is a larger group that encompasses the ACFR and a lot of other researchers across the university that might not traditionally be involved in kind of pure robotic research. So we're just going to talk a little bit about some of the projects that we've done in the past. This is one of the kind of early projects that the ACFR happened around about 25 years ago, was the development of an autonomous straddle carrier system. So these vehicles you see driving around, these are straddle carriers. They weigh about 60 tons. They're about 30 meters high. And, these sort of things are usually typically driven around in a container handling facility to kind of move containers around a facility. We had a project, probably it started about, I think it was about 25 years ago. It might have even been a bit earlier than that, that looked at basically trying to automate one of these things. So equipping it with a bunch of sensors, LiDAR, radar, vision sensors, and automated control algorithms that would allow these things to kind of drive themselves around in a safe way. So these are really big platforms. When human operators of these platforms make mistakes, then there's a potential for a lot of damage, and these can be quite dangerous. So it's quite a difficult kind of task to try and figure out how to kind of automate these, even though they work in a relatively kind of controlled sort of environment. And this is one of the early projects that we had. We actually have these systems have been running, I think it's for about 15 years now. There's a container handling facility in Brisbane, which is completely automated using these sort of systems. These are basically kind of driven around 24 hours around the clock, and they have like a control station that's operating and monitoring how these are going, from a remote facility that can operate outside of Brisbane. So these are kind of real applications of robotic systems that's come about from some of the research that's happened at the ACFR. We've got a pretty big marine robotics group. This is our marine robotics group deploying our Sirius AUV. It's a 200 kilogram, kind of 2 meter size platform that can go under the ocean. It's got a whole sensor suite for imaging through the water and also seeing things on the bottom of the seafloor. And this is used in lots of different applications. We've been running, this thing has been doing repeated observations of marine habitats all around Australia over the last, since I think we had this platform in about 2007 or something like that. So for a large time now, and it's used for repeated monitoring, used in applications such as archaeology, marine archaeology for studying environments where it's too deep or dangerous to get divers down to. And,
so Mitch, it's Stefan. I'm leading that. I'll just to point out that the video you're seeing at the moment with the AUV in frame was actually done in Greece at offshore of an island called Antikythera, looking at a shipwreck from 83 BC. So we do get to get around the place and see some pretty exciting parts of the world through this program.
Yep. So there's been Steph leads the marine robotics group in the ACFR, and this is one of those really interesting applications. It's Steph can maybe talk a little bit about some of that work if anyone has any questions. So this I think is a list of all of the sites that have been visited since about 2007 using this AUV along with some other platforms. And repeated years of observations of and potentially millions of images and different parts of sensor data that have been collected around the habitat to kind of look at how marine habitats evolve over time. So a lot of applications in mapping habitats, where the presence of habitats are, and how they're going to be affected potentially in the future from things such as climate change and other types of effects in the environment. So the program works very closely with marine ecologists and other marine scientists to use these kind of robotic technologies to measure habitats that they've never really had an effective means of being able to measure. And you've probably heard people talk around about the ocean floor as being the kind of the final frontier, and there's a lot of parts of our ocean floor that we know less about than we kind of know about the other surfaces of other planets that we've seen from space probes. So this is a really exciting area for robotics. We've got a group that looks at using robotic systems for mining. In fact, we've got a really, really large research group known as the Rio Tinto Miner Center for Automation, Center for Mining Automation, which is essentially started as a spin-off out of the Australian Centre for Field Robotics. And they look at things like autonomous operations of these kind of haul trucks, autonomous systems for geological exploration, and planning and scheduling operations using these massive vehicles over a mine site, and all of the implications involved with safely operating these massive vehicles, ensuring where people are on a mine site at a given time. You can kind of imagine driving these haul trucks. It's very difficult to kind of see what's around you. So having that kind of systems that are built up kind of networks of sensors to kind of work out where people are on the site, make sure people are not in harm's way as you're kind of operating these vehicles. We've got a group that looks at building agricultural robotics. So this is a Ripper platform, which is used basically for autonomous sensing of crop rows, and being able to also do things like manipulate what's going on in those crop rows by doing things like weeding, being able to apply fertilizer, and a complete automated solution to what a farmer would kind of do on a crop row. So this platform here is used for, has a bunch of sensors on board for mapping the health of different types of crops using different types of sensors. This is an example of an autonomous weeding system, a mechanical weeding system that's actually used to kind of what it's scrubbing out here in the dirt when it detects weeds. So having autonomous systems for detecting where crops are, where weeds are, and being able to remove those kind of in what would otherwise be a really manually intensive process for people to go out and apply this as farmers would. This is an example of using a soil-based sensor for measuring the soil properties and being able to kind of build maps about understanding nutrients in the soil and having a completely kind of automated solution to growing crops kind of in the future. And we have a couple of commercial spin-offs that have come out of this research. Agiris is a big agricultural robotics group that's come out. Got another spin-up that's been looking at more like tree crop applications using such as macadamias and apples and things like this from autonomous robotic platforms. This is some work from our robotic imaging group. I might hand over to Don if Don wanted to say a few words about.
Yeah, absolutely. So as we're looking at these different platforms doing these amazing things in challenging environments, one of the problems we run against is how can we let these robots sense their environments reliably and repeatably so they do the same thing every time. So the application domains really are wherever normal cameras aren't doing the job, and you discover pretty quickly how broad that is. Some of our recent work is in underwater robotics, but also vision for the blind. So we're working on a project designed to help the visually impaired sense their environment by putting sensor suites on a pair of glasses to look out into the world, and then relay what they're sensing to the user through an audio display. We somewhat more exotically have been doing some work on figuring out how we can sense reliably in extraterrestrial environments, including some work to go to the moon and endow robots there with their special needs, especially around polar exploration with capabilities to sense reliably. Mitch, if you'll give a play to that video on the top right, that's showing off, whoops, there we go, thank you. Just the very fundamental problem of if there are clear things around, that tends to break vision. And this is showing off some of our work, and you can see here a robot detecting parts of the environment that are transparent autonomously. It's a surprisingly challenging thing to do, but we think we've cracked the problem with a specialized kind of camera. Really quickly, some of the other challenges we look at are nighttime operation, how to stream VR live, how to work around highly unstructured natural environments, and how can we leverage machine learning to do all of the above and to work with new cameras. So if we can go to the next slide, Mitch. So a big part of this is let's go ahead and design the camera for the job. We know nature does this. Different animals have hit different evolutionary niches because they have different needs, and so should it be with our autonomous agents. So here are some of the cameras we're working with in the group. We've designed and built most of these. The spherical lens camera is out of some work I did while at Stanford. Epi Imaging is a startup in Silicon Valley I'm working with. And these are some open source and customizable light field cameras I've built with some students. And down below, Mitch, thank you. This is a startup out of QUT that we've built to image the backs of people's eyes using light field technology. And some recent work out of our lab with Jack Naylor, Adam Terrace, and others to build 3D hyperspectral sensing. So the future is bright. Emerging technologies like single photon detection, Doppler LiDAR, vision on chip approaches, these all apply. And the problem, of course, is with the range of available emerging technologies, how do we adapt those to let robots do new things and operate across environments? So over the next two slides, just to show off a bit of our field deployments, if we can go on, Mitch, on the Nautilus, we got to deploy some light field cameras a few years back. And if you can advance the slide, Mitch, through the images, we stuck this camera on their ROV. And in the next image, you can see the sort of environment we're working in. You can't see too far when it's murky water, but we established that with specialized cameras. And with the next image, you can see we can get some nice, sharp, crisp, high detailed imagery by basically designing the camera for the task. But the appropriate camera is different for different jobs. So if we stay underwater but go somewhere else, like this was Antarctic. Yep, thanks, Mitch. Well anticipated. Now here, the idea was to stick another light field camera onto a sled, which is not very maneuverable, but it's good enough to go ahead and image some clouds of, what are they going to be? Krill. And krill get right up in your face. There's a huge depth of field problem here, but with the specialized cameras, we were able to improve the imaging so that we got something more like this, able to capture the krill despite their huge depth of field. So the take home there is by designing cameras for the job, you can see much, much better. And when I say much better, I mean the difference between a robot that could not really do its job, which is in this case to perceive krill, but it varies by application. One of my students is really motivated to get pizza delivery to work at night, right? How do we make robots that can fly at night and deliver pizza? We need to design the cameras for the job. And so that's the kind of research that we get up to. If you want to know anything more about that, please do approach me anytime. I'm very happy to talk about it. But I think the next slide is very much back to, is Stuart here?
Yeah, so this is a group that we have that involves Professor Eduardo Nebet and Dr. Stuart Worrell, who actually gave a talk to this group a couple of weeks ago and probably went to a little bit more detail about this. So we've got a group that looks at autonomous driving and some of the kind of core technologies involved in the tasks such as controlling vehicles and the perception of the environment around you, seeing pedestrians, understanding what their intentions are going to be, and understanding how to obey all the road rules and all the interaction that happens between cars in these kind of busy environments. And obviously this is a really big area of robotics that's going to be really important over the next decade. We've got so these are some of the, some of the work that's gone in here, which I can come back to, and probably Stuart went into a little bit more detail into as well in terms of perceiving what's in the environment. We've got a group that looks at aerial perception, so autonomous aerial vehicles, a lot of work involving doing things like sensing and mapping and scene understanding using vision sensors, hyperspectral imaging sensors, and laser scanning from aerial platforms, and trying to develop some sort of low cost and cost-effective imaging technology so that drones can go out there and collect information in a range of different environments, such as in agriculture and in forestries. We have a research group that focuses specifically on forestry remote sensing and robotics. So a lot of this is using drones and other aerial vehicles to scan in forest environments, which have a number of kind of unique challenges in terms of the structure of the environment. And so this is an application such as, the future of our commercial and also our health of native forests, and doing things like looking at commercial operations, tracking forest health, and managing things such as forest fires. We've got a research group that's led by Viorella Isla, which is mainly looking at mapping and scene understanding from robotic vehicles. So a lot about how robots move around in their environment, use sensor information to build up a map or a structural picture of what's around the environment, and then how they use that information to move around. A lot of research focused around the ideas of how do you do this in environments that include both static objects and also dynamic moving objects, and understanding how to recognize which parts of the sensor data need to be mapped into part of the static structure in the environment, while managing dynamic things moving around and including what's in the environment as well. And we've got groups that kind of spin-offs of this that come about from doing mapping and sensing and reconstruction of three-dimensional aspects of the environment in kind of difficult scenarios where you've got small objects, thin objects, objects which are non-rigid and kind of can move around and morph as you're trying to image them, and all of the sensor processing and perceptual understanding that goes into how to get robots to make sense of those environments. We've got a group that's looking at robotic control. So this is Guodong Shi and Ian Manchester and others in the group that are looking at a range of research topics around the control of robotic systems. This is the Cassie walking robot platform, which is something that we have now as part of ACFR and Cyrus. And I think Ian and could maybe be able to potentially tell us more about this. So, looking at how we develop algorithms to control these kind of systems that, have all these issues associated with the stability of the platform under different types of walking scenarios, and how we combine, perceptual systems with control, and, how things like deep learning and machine learning technologies come into getting robots to learn how to control themselves. So, ACFR is a pretty wide range of diverse kind of research topics that we're tackling around autonomous systems, robotics, intelligent systems. Some of the applications areas that we're kind of moving into, we've got a group now that a lot of applications looking at things like space robotics, things like in-orbit robotics, lunar planetary rovers. A lot more applications starting to kick off now in medical robotic applications and robotic surgery. And this is some of the research areas that we'll sort of be continuing to tackle into the future. So I guess there's a little bit here about some of the recent kind of robotics facilities that we've got at the moment. This is one of our new, or it's been around for a couple of years now, Groundhog kind of custom mobile robot platform that we can use for lots of different research with our Cassie walking robots. This is our field robotics lab, which is just located just about a kind of 10-minute walk away from the main engineering precinct in sort of near Abercrombie Street. And we've got a robotics imaging lab, which is based at J04 in the engineering, at the ACFR building in engineering, and a number of other kind of robotic platforms and systems that we've kind of recently made available as part of the ACFR. I guess the last thing I wanted to just talk about really quickly is if there's any kind of final year students here, something you might want to consider or kind of think about is if you wanted to get involved with some of the research projects that that's happening at the ACFR is considered postgraduate studies such as masters or PhDs. Some of the things you think about, having a 3 to 4 years to run your own research project, supported within the Australian Centre for Field Robotics. Another number of academics here that you could potentially get in contact with and talk to if you are interested in getting involved in this research. And the other thing I should also mention, obviously, is that every year we have a really large number of honours projects for the final year honours thesis that are run across all of the different research projects that we've talked about today. So this is another way, obviously, to get involved in the research that's happening at the ACFR. I thought now I might hand over to Ian, who can tell us a little bit about. Did you want to?
Yeah.
I'll stop sharing my screen.
Yeah.
I'll let you share yours.
Okay, can you see that? Yeah. Okay, so hi everyone. My name is Ian Manchester. I'm a professor of mechatronics and I'm the director of the Australian Centre for Field Robotics. So Mitch has given a bit of a fairly broad overview of what goes on in ACFR. I wanted to focus a little bit on something new, which is just starting up. It's called the ARC Research Hub in Intelligent Robotic Systems for Real-Time Asset Management. This is a center which we just got funded for a few months ago. It's a 5-year program, $10 million in funding. We're probably going to kick it off early next year, and we're expecting probably somewhere in the realm of 30 to 40 students and staff to be working on this over the next 5 years. So I thought, you guys as kind of coming through the undergraduate program now, those of you who are thinking about maybe doing robotics research after you graduate, this is something that might be something to think about. So what's it all about? The kind of idea behind it is you might have think about some kind of real physical thing existing in the world. So it could be a bridge or railway or kind of wind farms, solar farms, offshore oil platforms, whatever, some kind of big outdoor infrastructure. And you want to know what the state of it is. You want to potentially do inspections of it, maybe even do repairs on it, repainting it, whatever. You want to kind of keep it in decent shape. And so the idea of that is that you actually have what's called, you might have heard the phrase, it's a bit of a buzzword at the moment, a digital twin, which is basically some kind of digital representation of the real asset, kind of like a CAD model, but it represents real-time information of what the current state is. So the question is, how do you keep it real-time? So how do you keep updating it with, if the asset changes, if something breaks or something needs repair or kind of wears away over time, you want to keep that updated. So basically we have proposed, and what we'll be working on is robotic systems for doing this. So you kind of break this down into using the digital twin, figure out where the robot should go. So you might think about things like quadrotor drones inspecting wind farms, marine robots, like some of the ones you saw earlier, looking at undersea infrastructure, that kind of thing. So you use the digital twin to plan where the robot will go. You're then executing a mission with the robot, kind of, it might be a robot that needs to get very close to some underwater pillar in strong currents. So you need really good. So basically you've got a real thing out in the world. Think about a wind turbine. You've got you want to keep some digital representation of it, keep it live and keep it up to date in what the, so that you can kind of track what's happening. So the robotic system will be kind of planning a mission about where the quadrotor should fly around that wind turbine. Then you've got to execute the mission. So you need really good flight control systems, good collision avoidance and so on. And then you have various sensors on board. So we've got people like Don, for example, who work on sensor systems, and you'll be kind of inspecting, maybe analyzing what's going on. And you'll be then building that into some big map, which might be even a kind of a spatiotemporal representation. So of how the thing in the world is changing over time. And you use that to kind of update the digital twin. And then there's kind of this continuous loop of continually updating, planning, perceiving, and so on. And then eventually maybe also robotic intervention, maintenance, and so on. So there's a bunch of people involved in this, not just at Sydney Uni. We're leading it, and a lot of this is kind of the academic team involved. You'll see that kind of most of them are USyd, but we also have people from QUT, which is kind of another one of the big robotics groups in Australia, and a few from ANU who have a very strong team looking at computational methods for planning. And kind of the way that we've broken it down is we've got 3 fundamental research themes. So there's planning and control, sensing and perception, and mapping and insight. So these are kind of the basic science of robotics that feeds into this, these kinds of capabilities. Then we've got a program of kind of translating that into industry impact, involving some capability demonstrators. So this would be things like the kind of DARPA Grand Challenge style thing. So I don't know if you might have seen the Subterranean Challenge a few weeks ago, that kind of event where we're kind of showing off robotics capability, and then a program of actually kind of getting this out into industry, cutting across those fundamental research themes and the kind of translation to impact kind of programs. We've singled out a few, I guess, capabilities that we really think are where robotics needs to advance. So one of them is mission planning for information gathering. We've got navigation and control in challenging conditions, active perception and manipulation, and spatiotemporal mapping and change detection. So these are, I guess, the new thrusts that are kind of coming from this research program. And then we've also got a few kind of non-research related programs. So there's Guodong, who's on the line, I think will be running the research training and mentoring scheme. Robotics, unfortunately, historically has been quite imbalanced from a gender perspective. And so Hannah Kurniawati from ANU and Virella Illa from Sydney University are going to be leading a program kind of looking at that and looking at how the hub can really be instrumental in kind of making a step change in that situation. And then Mitch, who you just heard from, is leading the public outreach and engagement program of the hub as well. So it's not just academics. I thought I'd maybe spend a couple of minutes talking about some of the companies involved. So it's actually the way this kind of research hub works. It's half funded by the government, half funded by industry. These are our industry partners on this program. You may have heard of some of them, maybe not. I'll just kind of go through, give a little bit of info about what some of them are doing. So we've got some that make robotic systems. So this is the Magneto robot made by Nexus, which is designed for kind of crawling around inside, kind of inside confined spaces. It's basically a spider with magnetic feet, and it can do things like crawl inside pipes, inside pressure vessels, fuel tanks, that kind of thing. This is the Msn Hover Map System. Actually, what Msn make is not the drone itself. It's this kind of box underneath here, which is, this is a laser scanner here, and then you've got some compute on board here and communications and power. And this is a system for 3D reconstruction in kind of very challenging environments. So they do a lot of work looking kind of down mine shafts and looking in, looking at kind of power lines and a lot of those kinds of, ship superstructure, that kind of thing. So they were actually on the team led by CSIRO that came second place in the DARPA Subterranean Challenge a couple of weeks ago. You might have seen that. They were, this close to getting first. I think it was they were only just off on the points from first place. So that's pretty cool. We've got a few companies that really look at, I guess, this digital 3D reconstruction, digital twin representations and so on. So one company looking at Abyss, they're a spin-off company from the ACFR. So some of our former PhD students went off. They do marine robotics, but they also do this kind of 3D imaging and reconstruction of marine infrastructure and looking at things like kind of real-time damage assessment on in complex infrastructure systems. And then another company called Nearmap, which is a Sydney-based company, but they've really got global reach now. Think of this as kind of super high resolution and high frequency updated Google Maps. So they build 3D high-res maps of things, and they revisit places on, several times a year, so that it's really up to date. And then they have kind of layers on top of that of machine learning to provide insights. And what we're working on with them is, okay, so they do aerial imaging of stuff, but then if you wanted to augment that with robotic imaging kind of closer to the ground, then that's a way that they can really add a lot of fidelity to their models.
Worth mentioning also, Ian, that some of our former PhD students are there doing work on classification, and that they also take a lot of ESIPs, Engineering Sydney Industry Placement Scholarship students at NearMap every year. So good opportunity if you're interested in that kind of thing.
Yep. So a few of the other companies involved are kind of building things here in Sydney as well. So Advanced Navigation are a company, they do all sorts of things like inertial measurement systems, acoustic sensing systems. So this is an acoustic sensing system that they build for marine robotic systems. It can do, can be used for things like collision avoidance, but also velocity estimation by bouncing sound waves off the seafloor, that kind of thing. They're also developing their own marine robotic systems. There's a company called Hullbot. They're making a new robotic system for cleaning the underside of ship hulls. Think of it a little bit like a pool cleaner robot, but it goes underneath ships and cleans the bottom of those. And then there's another company called Engine Room, which is focusing really on high performance computing, especially in kind of machine learning, data analytics, kind of big, rooms full of GPUs. But they're actually also designing and building their own custom cooling systems for those to get kind of extra performance out of them. And then we've got a couple of companies or organizations that really manage really complex infrastructure. So this is the Opal nuclear reactor at ANSTO, and they're one of our partners, and they're very interested in robotics across a spectrum of applications. So monitoring, maintenance, material handling, that kind of thing. And then Thales is a partner. Thales is a large French multinational kind of corporation, but they've got a big presence in Australia. They actually also do marine robotic systems. They have an underwater systems group that we have a long history of collaboration with. But they're also responsible for managing the Australian Navy's fleet at Garden Island. So basically doing all the maintenance and inspections there. So they're very interested in getting robots to kind of fly around and crawl inside and swim around underneath and do a lot of that without actually having to pull, or do a lot of that before they pull the ship up, so that they don't not kind of met with nasty surprises when they actually get the boat into dry dock. So those are, I think I guess the important thing here is that it's not just the academic research here. We've got some really innovative and exciting companies on board with this hub as well. So there's, as I mentioned, this is going to be launching early next year, but there's going to be loads and loads of opportunities over the next 5 years to do PhD research and masters, that kind of thing. So do get in touch with us if you're interested in that. I had another couple of slides. I think Mitch kind of mentioned this already. This is the Cassie robot. So this is, we actually got it delivered kind of just before COVID hit, and it's been sitting kind of almost doing nothing since then, because we haven't really been able to get a lot of time in the lab, but we're hoping that'll change a lot next year. And so this is a biped walking robot. Mitch showed you a video before, but we're building a big team of people to work on kind of all aspects of planning, control, perception for kind of bipedal walking over uneven terrain, urban environments, outdoors, that kind of thing. And then I think Mitch also mentioned, so this is the new surgical robotics facility that we've built in collaboration with Sydney Medical School. So this is a KUKA robot arm, is kind of, and it's certified for use in surgical settings. And then this is actually a CT scanner. I'm sorry, this is it's called the Artis Pheno. It's actually a giant KUKA robot inside as well, but then Siemens put a CT scanner on the end. And so it's basically a giant robotic CT scanner that can kind of twirl around. The patient can be lying here on the bed, and this can do a full 3D real-time CT scan. And then while the patient is on the operating table, and then give 3D information to the robot, which can then use that information during the surgical process. So this is something we kind of have just got set up over the last year or so. And it's also another area that we're looking to recruit kind of interested students to kind of help us do cool stuff with. So that's all I had. I'm happy now to, I guess, open the floor to questions, or pass back. Mitch, do you want to, or who's, or one of the students, pass back to the host? Who's running this thing?
That's right.
Yeah, if everyone has any questions, you can put it in the chat, or feel free to unmute yourself and speak.
Yeah, we didn't have anything else to present, so happy to take any questions now.
Yeah, I'll go. So you guys mentioned that one of the big partnerships you did was with Rio Tinto with RTCMA. Do you see yourself, or ACFR, I guess, doing something or any similar size partnerships with any other companies in the same way, in that creating a whole separate division in a whole separate building, like you have with RTCMA?
I think it's possible. We have done similar things in the past as well. So we had one with Qantas a few years ago, and you can read about that online. It was featured in like the Australian Financial Review. We actually completely redesigned Qantas's flight planning system, which, well, once they actually start flying again, we'll be saving them lots of money. And so that was kind of we had a dedicated, not a whole building, but a kind of a dedicated wing of the center, which was all the people working on the Qantas group. I think there are other areas that we're kind of getting into that could potentially get to a similar scale. Mining industry is a little bit special in Australia. There's not so many other industries in Australia that have that level of, I guess, money that can be invested in R&D. So I think RTCMA is definitely the biggest that we have had, but we've had kind of similar but smaller engagements come and go, and I think that I expect there will be more over time as well.
Cool. Thanks for that.
I had a question.
Roughly what percentage of people get poached by the military? I don't know that many. Get specifically by the military, probably not many. There's probably quite a number that go and work for companies that have some engagement in the defense industry.
I think we're mainly good at building robots. I'm not sure we'd be make very good soldiers, any of us.
Yeah.
I don't know about you, Ian. Me and Ian have got glasses, and we'd probably be a bit I think we'd be a bit precious about getting hurt if we were in the military. I think there's a lot of applications that we do in the civilian sector, I think, is at the moment. But we have had some involved in defense related projects in the past.
Yeah. So Will has a question. What are the advantages and disadvantages of going into research versus the workforce after graduating? I mean, that's probably a different conversation with every individual who's considering those options, I think. Obviously, going directly in the workforce is probably going to give you a greater income in the short term. I think the benefits of going into research are probably more about, on the one hand, perhaps the longer term prospects. So certainly if you want to get into very high tech, like cutting edge R&D, whether it's, it could be staying within a kind of an academic environment or getting into the kind of industry, but in R&D group, then doing a master's or a PhD is really an excellent way to do that. Another thing that Don mentioned, I guess, is you really get a lot of autonomy when you're doing a PhD. So you don't have somebody kind of telling you what to do. You kind of are your own boss essentially for 3 to 4 years. You've got an advisor, but there's a lot of self direction in terms of where you take it. Your thesis is really your own thing, so it really allows you to do a deep dive into an area that interests you and just focus on that for a few years. So if you're the kind of person that likes to really dig in deep onto a particular area and just know everything about it, if you got that kind of slightly obsessive characteristic, then I think research is a great thing to get into.
So
another
thing I'd say, Ian, is it's not only about research as well and sort of academia. And I don't know if Mitch showed this slide, but this is one we put together when sort of a presentation that Don and I did a couple of weeks ago about the value of a PhD. And these are all spin-offs, largely from the ACFR, which are led by former PhD students. So there's companies here doing agriculture, building sensors, marine robotics, military training systems, med tech sensors for obstetrics, space, and biotech. So all of these students have come through ended up doing a PhD and, not gone that traditional route into academia, which a lot of people think is a PhD, but gone out and said, well, I'm going to go and create my own job and set up companies. And a lot of these are doing very well, actually. There's
the third option too, right, Steph? It's sticking in academia, building your own company, or getting a job. A lot of our alumni, I think you might have an adjacent slide that shows some of the places our alumni have ended up the other direction, who don't go on to make their own companies, but who join companies.
I have that in this version.
Yeah.
Okay. Your version.
Right. So we've had alumnus that go to Waymo, into Europe and into the high-tech industries there, into Canada. Our employers are all over the planet and all over Australia. And the trick, right, is, and this was what convinced me to do a PhD, was if you go out on the job market and you look at all your dream jobs, try to pay attention to how many of them are asking for that PhD. And if you're finding some or a lot of them are really asking for the PhD, then maybe it's the right thing for you. It's opened a lot of doors for a lot of people.
If you look at the companies that I listed in the ITRH, so all of them are doing really exciting stuff, and almost all of them employ a lot of people with PhDs to kind of drive that stuff forward. So it's definitely valued within the kind of, I guess, the most, well, what I think is kind of the most exciting sector of industry.
Yeah, so I think, it's not necessarily about founding companies, but you can be technical experts within companies, I think, with the PhD, and that lets you kind of step up into those really, I guess, deep technical roles in a lot of instances.
If you're willing to live the student life a few years longer, then there can be some big benefits.
And the other thing to mention there is a lot of those companies that Steph's put up here, a lot of those students were working on their PhD research was the foundation behind what they took off and started as a new spin-off company. So there's a lot of applied research that does happen, in the ACFR, for example, where you have an opportunity to then translate the research that you work for 3 or 4 months into the world when you kind of finish.
3 or 4 years.
Maybe another thing I might just add
3 or 4 months, I meant 3 or 4 years, sorry.
Another thing just to add is, I think mostly we've been talking about like the individual benefits of doing a PhD, but also, I mean, you guys, you're all part of SUMO, right? You know what a fantastic experience it can be to be part of kind of a community learning together. At the ACFR, we typically have about 30 PhD students at any given time. And, you'll be going through that whole experience with all of them. And, there'll be a really interesting group of people. Some of them will end up forming their own companies. Others will end up working for cool international companies. Others will become professors. And so it kind of, your network, both within ACFR, but also when you're publishing papers, you're going to conferences, you'll be, going to international conferences, presenting your work, meeting students from all over the world. We often get visiting students. You might be able to go on a visit yourself. So I think it really expands your network to be one of kind of a global network. Gets you into kind of a really interesting community of people.
And we got to probably also say that, the ACFR is not the only destination to do a PhD. We've got students all over the place coming out of these programs. Oh, sorry. But, we've got students who go off and do their PhDs at Oxford and Stanford and MIT, and they all do very well, and they become part of our global network because we then find them at conferences and keep track of them. And a lot of our former students may end up working with colleagues. So I think it's a great environment to be in, I think.
While everyone thinks of more questions, I'll put the PEP form in the chat. So just fill that out when you want. Oh, there's one there.
What can you do to increase your chances of getting a position at ACFR through PhD or otherwise? Thanks for the question, Will. So there's probably 2 sets of things. The most straightforward and perhaps obvious answer to that is like your grades in your current degree do matter, especially for things like scholarships. So yeah, getting high grades is very, very useful for a lot of things. And basically when it comes to scholarships, you know, there's a certain amount of it which is just kind of ranking based on grades, and then these people get scholarships, so basically getting paid a salary to do your PhD. So that's kind of the obvious thing. But there's plenty of other aspects as well. So a lot of my current or former PhD students have been people who have either done an honors project with me, or some of them have done like a special research project or like a summer or winter project. So just kind of finding, you know, you can find various opportunities through summer and winter programs or the honors programs to get involved with ACFR, get in the lab, and you know, start working on some projects, start working with the group, and those are excellent as well, I think.
So I would like to add to that. Next week there will be the seminar day. Everybody is welcome to join the talks, especially the presentations from the ACFR thesis students. Right, you can get first-hand experiences regarding what kind of projects you can get into, and you can make contact right after that, right?
There's a question, are these opportunities advertised? So we're actually working on getting better information out there about what the opportunities are. And maybe it's important to clarify, I guess, when we're talking about PhD study, then there's kind of two different types of opportunity there. And it's to do with the particular way that stipends are funded. One kind of opportunity might be we have particular funding to do research in a particular area. For example, the research hub that I just mentioned, and this funding from industry and government funds a certain number of PhD stipends, and then those will be advertised. It's basically like a job ad, you know, these scholarships in these areas are available, and people can apply for those. On the other hand, there's also, you can also apply to do robotics in like areas which don't have specific project funding allocated to them, and then you can apply for a scholarship, and that can be kind of based on your own record. And so it kind of can be like the student gets funded to do the research, and then it can be in almost anything. And then you can basically just talk to any of us, talk to any potential advisor. And if you've got a strong record and you've got some interesting ideas for projects, or you're interested in talking about potential projects, then you can kind of get in through that pathway. So yep, there's a couple of links going into the chat where there's some information. I think but we're actually kind of currently working on improving I guess the depth and the detail on the information that's out there about those sorts of opportunities.
So the faculty is also setting up some new pages to advertise both projects and supervisors, and sort of connect potential students. Dawn's the I forget what the title is, but postgraduate coordinator for the school, and so can give some advice on where to find those details, and we can certainly post opportunities to whatever your favorite medium is. I know we used to use the student clubs and societies as a means of disseminating information. So if you still have a mailing list and you'd like us to be sending opportunities out, we sometimes use the school Canvas page as well to post details.
I guess to be complete, we should probably give the strongest advice to someone who thinks they might be interested in research, which is to find a potential supervisor who's doing things you're interested in and get in touch with them, have a chat. Most of us are more than happy to talk to you about your interests and what you might like to accomplish, what you might like to do. And any of us would be able to point you in the right direction for any emerging opportunities, or help you steer towards a project that might be a good match for you. So don't hesitate to contact any of the people here or at the ACFR and just say, hey, I'm interested in research, have a chat with me.
Yeah, and as Ian said, a PhD is largely about your thesis. It's usually undertaken within sort of the context of an ongoing research project, because that's where there's funding to do interesting, exciting stuff. But largely it needs to be driven by yourselves, and for me, the first thing I do is I usually ask students to tell me what they'd like to do. Send me a little proposal. We work through that and think about research ideas and areas and craft up a proposal. That's part of the application process anyways, but that tends to be something that I like to see students initiate, but then help kind of shape that into something that I think has legs.
There's another question in the chat about requiring a stipend or work while otherwise supported. I'm not sure I quite understand what that question is asking. Maybe the person asking could, do you want to unmute yourself and jump in? I'm also not sure what the name of the person asking that is. CKNE.
So I think someone asked whether there's opportunities to apply to do a PhD if that's independent of the process of getting a stipend or a scholarship. They are.
Yeah. Okay.
Yeah.
Or if they have their own funding.
They are separate.
Or they've clarified with it's independent funding.
Yes, it essentially is. So there's kind of a few different ways that can be done. One way, maybe there's a third way that I didn't mention. So I mentioned it could be directly funded by a project which is looking for PhD students to solve or to work on a particular research area. And that's that in that setting, you kind of I guess the broad area of research, at least, and maybe even quite specific, is already kind of determined. And we're looking for the student that matches with that, interested in that. The second category, which I mentioned, is basically a student with a strong set of marks, good weighted average, and a good idea for a research proposal, can basically just come in and attract their own funding from the government's research support scheme. A third category is you could just apply to be admitted to the PhD program without getting a stipend if you kind of have independent financial support, and that is also possible. There are students, actually quite a big number of PhD students across the university are self-funded effectively. So they're kind of paying, basically like paying student fees, tuition fees, in the same way as you do for an undergraduate program.
Although, am I not mistaken that domestic students don't pay fees?
That's true. Yep.
PhDs. It's
so domestic students. So that's If you're a citizen or a permanent resident, then the PhD tuition itself is free. But the question is whether or not you actually get paid a salary to do the research. So it's the stipend is currently about $35,000 per year, which is tax-free. And then most of our students do a bit of tutoring on top of that. So there might be an extra 10 something K per year on top of that. So that's the stipend, and the stipend is competitive. Every domestic student gets free tuition. If you're an international student, so not a permanent resident and not a citizen, then there are tuition fees. But if you do get a stipend, either through the competitive process based on your marks or funded by a particular research area, then you don't have to pay any tuition fees, and you get paid the stipend. So yeah, hopefully that's clear. But basically, there's a range of different ways it can work.
There was a question about opportunities for internships or helping out with any ongoing ACFR projects or PhD projects. We do have summer and winter research projects that get advertised every year that I think are open to all of our students.
So I think the official summer program is probably, has that closed already?
Yeah, I think I've got the list.
But I think if you, I think that we do have these kind of official summer and winter programs where you can actually you can also get a stipend, so you can earn a few $1,000s to do some work on robotics over the break. That's closed for summer, but there'll be one next winter. But you can always just get in touch, if you're keen and you're not interested in, or you're not worried about too much about getting paid to do it, but you're keen to get involved, just contact some of us, and often there'll be opportunities to to help out in one way or another. If you want to just, see what goes on in the lab and, get in contact. There's often opportunities for undergrads to help out on various projects. So the short answer is,
the other thing to point out, Ian, is that we were also looking at sponsoring a couple of student teams. So we've got a Robotics unmanned surface vessel competition, which will actually be hosted in Sydney next year. We've got about a dozen students interested in that. So we're looking for students over the summer to get involved and be involved in the Robotics program, and I'll post a link to that. And then we're also looking at a lunar rover program, and there's an Australian competition that's being sponsored by NASA. We've got some funding recently through the Australian Space Agency to do work, and through Mitsubishi Heavy Industries in Japan to do work on designing lunar rovers. So if anyone's interested in that kind of area, it's quite likely there'll be a team there as well. Does the best rover actually get to go to the moon? Well, just last week, the Australian Space Agency announced that they were going to put either $20 or $50 million into putting a rover on the moon. I think I got about half a dozen emails from different people saying, hey, have you seen this? We should do this. So maybe.
I think there's some possibility of that. So we're actually working with both the Australian Space Agency and with it, as Steph mentioned, through kind of the Japanese Space Agency, both on lunar rover missions. So can't promise it, but maybe. A couple of our former students have actually ended up at NASA JPL and are kind of working on rover systems. So that's kind of one of the kind of exciting job outcomes of that can come from doing a PhD with us.
And I did see actually just today, I saw something, there's a competition that we were asked to circulate, and I'll try to get details of it, but it's a sort of scale size autonomous car competition. So if anybody's interested in that, there may be opportunities to get involved. And Caltech is running an engagement program to design space missions, and I think there's some kind of attendance, and NASA is going to be doing the judging. So have a look on the school Canvas announcement sites. I posted something about that today.
So I think Solar, I think, has advertised the lunar rover thing, right? Is anyone planning to get a spot from Boston Dynamics? There is actually potential for that as part of the ITRH. Actually, the program lead on the spot, who kind of designed the spot and is running that program at Boston Dynamics, is an old friend of mine. We were studying together at MIT, so I know the spot pretty well. I worked on an earlier version of it. But yeah, there's a high chance we'll get something like that. We've got the Cassie Biped, but in the DARPA Subterranean Challenge, the team that our collaborators Msn were on was actually also using, I showed the drone with the Msn laser scanner, but they also had a couple of spot robots with the Msn scanner on board as well. So if you look up the Subterranean Challenge stuff, you can see the kind of thing that was going on there. So yes, we'd probably be doing similar stuff.
So I just found the email. It's the Bosch Future Mobility Challenge, which is for 2022. So Bosch will provide a 1 to 10 scale vehicle, and there's some competitions. So they're looking for 2 to 5 students at the high school, bachelor, master's level to work on these autonomous cars, and registration by the end of the month.
So this is kind of similar. Don, there was the droid racing. Do you know if that's happening again? Or is that kind of being shut down by COVID?
This year. I hope so. It's been run at QUT a few years, and it was really good fun. Our students did extremely well in it. Something else to watch out for is the Robotic Vision Summer School, which is going to have a node in Sydney again this year, and for the first time is officially open to undergraduate students. So it's a 1-week event where you get up to speed really quickly in robotic vision. There's a competition element to it. And it's a great way to meet like-minded people if you're interested in robotic vision. So all kinds of events to watch out for.
Okay, so thanks all. Hope that was helpful. And if you're interested in any of the, in hearing more details of any of the programs, I think any of us would be interested in giving talks about the work we're doing. So thanks all.
Yeah.
I'm gonna head off.
Just send us an email.
I just want to say thanks to Tara and the SUMO team for inviting us to come talk today as well. Thanks.
Yep.
Yeah,
And thanks
you
everyone
for
who
coming
asked questions as well.